Hello everyone. In this session we learn about Hopfield networks. Hopfield networks are a type of recurrent neural networks which can store memories and recall memories. Means these networks they work like our human brain neural network system, where neurons in our brain they store the patterns of real world. These patterns are connected through a synaptic connection. The synaptic connection is nothing but associative memory, where each neuron in our brain stores some kind of a memory or a pattern of a real world, and these edges show the associative memory. So when we come across any situation, if a particular scene matches with our pattern, these memories will activate these neurons, and action is taken. Means the same process of storing a memory and recalling the memory that is included in our Hopfield networks. Let us see a small example. In this diagram, suppose there is an image like this, where a box of 9 square boxes are there. We human beings, we see the image and we remember this image. Next time when we redraw or reproduce the same image, what we do, in our neurons, these patterns of this entire image are stored. If at least we give one hint, like a small pattern as one input, the remaining patterns in first step, if I get this input, this neuron that is storing this pattern will fire, and associated memory with the other neuron also gets fired. A new pattern is reproduced. Based on these two, other neuron will get activated, it will draw third one. Like this, at each time step, we can regenerate or reproduce the image that we have learned. The same thing a neural network also. We prepare a neural network where a neuron stores this one pattern of these things, and edges they store the memories. So a small input to the neural network, if we give it, the remaining patterns in that image are reproduced. This is how a memory can be stored and recalled whenever we require some output from the neural network. So there are two main important processes in this Hopfield network. One is storing patterns, another one is recalling patterns. Let us go through the steps involved in storing the patterns. As regular neural networks, first we prepare a weight matrix. This weight matrix represents the strength of the connections between the neurons, and we apply a Hebb rule. Hebb rule says that neurons that fight together should be wired together. Like suppose in our brain, suppose there is any image. One neuron stores one part of the image, another neuron stores another part of the image. These two neurons should fight together, then only we can reproduce that image. So we should give highest strength to the memories which have a neurons that can fire together. And we prepare one energy function. Here Hopfield network uses a energy function, which is energy based function. That will take the concept from physics. So the free energy of a closed body should decrease over time. The same energy function we use in our Hopfield network, that is, it is called energy based model. I tell you how this energy function is used while preparing a network. So there are three steps. First we have to prepare a neural networks with the strength of with the weights that corresponds to the memories, and then we apply the Hebb rules and energy functions. and we have 4 steps. First, while recalling the patterns, first we have to prepare a noisy input and we update the states. Then finally, using energy function, we have to get one final stable state and reconstruct the pattern. Let us see with the example how this Hopfield network works with a diagram. Now, see, this is a simple neural network. In this neural network, so there are 6 neurons are there. I prepared my Hopfield network with 6 neurons, where each neuron stores the pattern, and a edge is a synaptic edge, nothing but associative memory. Here edges represent the memories, synaptic memory. These 6 neurons are connected together, and each neuron stores either 0 or 1 value. 0 or 1. 0 means no fire. 1 means our neuron will get fired. Means this neuron has a pattern that is stored in that neuron that is related to our context, and this neuron has no pattern in that one. Like that, we give either 0 or 1 in each neuron. So these weights represent how much strength is there between these 2 neurons in a particular scenario. Now what we do, first we arrange these neurons, 6 neurons, and we give weights like this, random weights we assign, weight matrix, we prepare a weight matrix. Then we apply a Hopfield rule, Hopfield principle. What Hopfield principle says that neurons that can fight together should have given high value, or that the neurons that has no related to our context also given value, because either fire or no fire means either they lit together or they do not lit together, means we are generating some memory from old things. Some neurons are strongly connected, they are taken into consideration. Neurons that are not connected, if we give them strength, they can be removed, means next time while learning this can. That is why in first step what we give, assign +1 to the neurons, where edges where 1 and 1 are there, I give +1, or 0 or 0 also I give +1. Remaining cases where one neuron holds the pattern and other neuron holds the other neuron holds 0, I gave -1. Here it's a here +1 holds see here 1 0 I ascend -1, 1 0 ascend -1, 1 1 ascend +1, means the neurons that fight together given +1 value. One neuron fires, another neuron stays idle, I give -1 value. Like this, Hopfield principle assigns some gives a value to each memory in this network. Now we combine these two, +1 and 0.5. It gives the 1.5, +1 0, it gives -1, -1 minus 0.5 minus 1.5, like +1 minus 0.5, 0.75. Like this we prepare, we finally store the memory. So this is the first step, first process in our network. Hopfield network is, you can assume it is completed. Now this is the stored memory now. Now this is stored memory where neurons store the pattern and edges store the associative memory. If the patterns they fight together means they can reproduce whatever we said. This is the final stored memory. Now second step is, after storing the memory, we have to recall the memory. Recall means, in my previous example I told you, suppose humans, first we store this memory, means there is an image with 9 boxes, each box is a pattern stored in one neuron. So this entire image we can say I represented now using, by giving some weights to the edges, I represented this image in this final stored format. Now while recalling the memory, recalling means here this by taking a clue from one pattern, I am reproducing this original one here, this target by time step 3. So I exactly reproduced the same image. So I start recalling from this phase, I have to reach this one, then only I can say my network successfully, it can store a image and it can recall that image. Now recall, this means when I recall this network, it should come up with these states only, means it should come to this stable state, then only I can recall. So that is the principle behind. So recalling step means reconstruction. The final state of the network represents the recalled pattern, which is typically the original stored pattern. So my recalled pattern should match with the original pattern. So this is my original pattern. Now I tell you the steps how a recall process work. So recall process means here I keep the weights as it is, means all these weights are fixed. I don't change any weights, but I change the values inside the neurons. Means your associative memory, while in our brain also memories are fixed, but the neurons over the time they change. See, when we born, our childhood, our brain, suppose it comes up with 100 neurons, memories are established between these neurons over the time for a long time. So what we do, we over the time we learn by adjusting these weights, and we learn different things and we try to recall. The same thing here, weights are fixed and things are neurons are adjusted with either 0 and 1. So first step in recall, let us see the steps in recall. I completed storing patterns. Weight matrix, first I prepared a weight matrix, then I applied a Hep's rules, +1 or -1 to each memory. Then I calculated the energy function. What is the energy function? Before going recall, just complete this energy function. So energy function is nothing but -1/2 into -1/2 into free energy. Free energy. Free energy means a free energy is nothing but sum of synaptic connections between two firing neurons. Ip's principle says that we should consider only the neurons that has highest strength or highest memory. So here first I calculate the energy of this entire model. Energy is like -1/2 into free energy. What is the free energy? So here neurons that has a connection by here 1 means the neurons that have a chance of firing, here 1 its value is only 0.75. There is no other neuron with 1 combination, only one pair. So it's finally its energy is -0.375. Whereas if we take this neural model of Hopfield, here -1/2 into there is 1 firing together, synaptic connection between two firing neurons. There is one synaptic connection 1, plus there is another pair 1 plus -2 and there is another pair -1.5. That means 1 -2 minus 1.5 into 1 by 2. Like this we calculate a energy function. This energy function for this model is 1.25. So here a Hopfield network says that the free energy of a closed physical system should decrease over time. A stable state would be at this state. Means whenever we prepare a model while recalling, we make sure that our energy function is decreasing over the time. Means at a particular time, if we reach a state where there is no more decrease in the energy, we can consider that as a stable state. So recalling always works, always wants to give a the output of a recalling process is the model that gives the lowest energy state that automatically matches with our stored pattern. So here in recalling process, I apply this energy. I try to find the lowest energy state and that lowest energy state should match with the original stored memory. So in next session I tell you how this recall process works with this help of this memory. Thank you.